So the sum of the first two terms of a geometric series is 7, and the sum of the first six terms is 91. So it's geometric, so the sum, I'm just going to say u1 plus u2 is equal to 7, where we know u2 is equal to u1 times r. So I'm going to rewrite it as u1 plus u1 times r equals 7, because we want to keep one variable. And so if I solve in terms of u1, I pull out a u1 by undoing the distribution and using the distribution rule, which is you get 1. When I pull out a u1 here, I get 1. When I pull out a u1 here, I get r equals 7. I divide both sides by 1 plus r. Boom. So u1 is equal to 7 over 1 plus r. And then it goes to say that the first six terms is 91. So I say S of 6 is equal to, well, I know in the geometric sequence using the formula, I have u sub 1, parentheses, 1 minus r to the power of 6, close parentheses, all over 1 minus r. And they're saying that is equal to 91. So I'm going to say 91 equals u sub 1, which is 7 over 1 plus r, which is times 1 minus r to the power of 6 over 1 minus r. So I can go ahead and multiply that in. So when I multiply, that's 7 minus 7 times r to the power of 6 over full this. That's 1 times 1 is 1. 1 times r is negative r plus another r. Negative r plus r is 0, so I don't need to put that. And then r times negative r, which is negative r squared. And again, this is equal to 91. Want to get rid of the fraction, so I multiply both sides by 1 minus r squared. So I get 91 times 1 minus r squared is equal to 7 minus 7r to the power of 6. Distribute. I get 91 minus 91r squared is equal to 7 minus 7r to the power of 6. I want to get all of these to one side. So if I get all of these to one side, I get 7r to the power of 6 minus 91r squared. And then minus 91 minus 7 is 84. So plus 84. Okay. Pass that. Okay. So then we factor out the 7. R to the power of 6. 91 divided by 7 is 13. So that's minus 13 r squared. And then 84 divided by 7 is 12, so plus 12. So naturally, when you factor, you want to factor, but you notice this is 6 and this is 2. So we're just going to go ahead. They want us to show that r squared equals 3. So I'm going to show that r squared is equal to 3 by showing that r squared minus 3 is a legit factor of r to the power of 6 minus 13r squared plus 12. So I do that by synthetic division. So I'm going to say r squared minus 3. Well, I think this is actually called long division. R to the power of 6. We don't have a 5, 4. So we're just going to use 0 r to the power of 5 plus 0 r to the power of 4 plus 0 r cubed minus 13 r squared plus 0 r plus 12. Okay, so r to the power of 2, I need an r to the 6, so I put r to the 4th. That gives me r to the 6 minus 3r to the 4th. And then we change signs. That's 0, that's 0. Then we get 3r to the 4 plus 0 r cubed minus 13r squared plus 0 r plus 12. I need a 3r to the 4th, so I have to add 3r squared. So that's 3r to the 4th. 3 times 3, that's negative r9 squared, negative r squared. So minus 9r squared. Change signs. That's 0, that's 0. 13 minus 9 is negative 4. R squared, 0, r plus 12. Negative 4, need minus 4. So that's minus 4 r squared. That's positive 12. Change the signs, that's plus. That becomes negative. That's 0, 0. Okay, so therefore, since we have a remainder 0, we know that r squared minus 3 is a factor. And the factor is r squared minus 3, parentheses. If I factor r to the power of 4 plus 3r squared minus 4, I can factor that into r squared plus 4, and then r squared minus 1. And so those are my factors, and I just proved that r squared equals 3 is a common ratio. And so it says, given that r is equal to the square root of 3, find the first term. So we can go back to this equation right here, u1 plus u1 times r equals 7. So we have u1 plus u1 times the square root of 3 equals 7. Actually, I do not even use that. I can use this right here. So 7 over 1 plus the square root of 3. I need to rationalize the denominator by going 1 minus square root of 3 over 1 minus the square root of 3. So if we follow that out, we get 1 minus 3. 1 minus 3 is negative 2 on bottom. And then we get 7 minus 7 square roots of 3. Clean it up by factoring out the negative and getting 7 square roots of 3 minus 7 over positive 2. That's for u of 1. And then they want us to find the sum of the first 8 terms. We need another sheet of paper because we're running out of room. You got another sheet of paper? Sum of the first 8 terms. You ready? S of 8 is equal to the first term, which again, the first term was 7 square roots of 3 minus 7 over 2 times 1 minus the square root of 3 to the power of 6 over 1 minus the square root of 3. And again, we have to multiply that. So square root of 3 times the square root of 3 is 3. So you get 3 to the power of 3. 3 times 3 times 3, which is 27. So this is equal to 1 minus 27 times 7 square root of 3 minus 7. Then this is 2 minus 2 square root of 3. We multiply this in, so that's 7. This is negative 26. Negative 26 times 7. Do that real quick. It's 42, 14, 18. So 182 minus negative 26. Okay. And so we don't want that, this on the bottom. We don't want that. So again, we're going to have to multiply by the conjugate. So 2 plus 2 square root of 3. 2 plus 2 square root of 3. So times that by 2 is 4, 6, carry 1, 5, 5, negative 564 square root of 3 times, again, 182, that's 4, 6, 564, and then minus, you get 564 square root times 3, and then plus 564 square roots of 3. So these cancel out. And then 564 times 3 minus 1, 564, which is the same as 564, 1 minus 3, which is negative 2. 564 times negative 2, that's 8, 2, 1, 11, negative 11, 28. Over 2 times 2 is 4. That's 4. 4. 2 times 2 is 4 times 3, which is 12. 4 minus 12 is negative 8. And so that becomes positive. 8 goes into 11 one time with a remainder 3, 32. That's 4, 1. 141 is the sum. So the sum of 8 is 141. That's it.